Okay, uh, welcome to the next slides. So, uh, in the slides, we'll talk about arrays and limitations of arrays and how to improve that array concept. So, we know what is array, what is an array. So, we learned about array in our previous course. Array contains, several data with the same type, but array has some limitations. So what are the limitations? For examples, if you want to increase or decrease its length, but which is fixed, you cannot increase or decrease its length. So if you specify the array size is 10, then you can keep only 10 values. If you have more than 10 values, then you cannot keep those values, extra values, to the array. So what you need to do, if you want to keep extra values, then probably you need to create another array, for bigger size. So you can think, so you can argue that we can make larger array, but that's not also a good way to do that, because you don't have idea how many value you have to keep. And if you create an array is a very larger size, then basically you are wasting memory spaces that if you probably you might not need all the spaces. So if you think in dynamically, that you don't have any idea how many values you are going to keep in the array, and you don't want to waste a lot of memory spaces, then array is not a good solution for that case. So this is the limitation of array. Then what are others limitations? For example, to add an element at the specified positions without shifting the other element to make a room. So we know that, so you have array and you want to keep some value in an array, then what you need to do, you need to shift, you know some you need to shift uh, all the values to make that room. So if you go to, say for example, let's go to some discussion. Say for examples, you have array 1 2 3 4 5 6. In that array you have, say, these value. So if you want to keep one more value at these positions, then what you need to do, you need to shift everything, you know you need to shift everything, then you can keep another value. So without shifting anything, you cannot insert any value at specific positions. So let's you can have something like this. Say for examples, say so this is the one idea. Say the another problem is that, for example, so you have an array, then you want to delete this one. If you want to delete this one, then what you need to do, you need to shift to the left everything. So this shifting right and this shifting left is not a proper operations. So you need more time to shifting. If you consider that you have millions of data in an array, then if you want to delete one element from that array, then you have to shift millions of data to the left side and millions of data to the right side, something like that. So shifting a lot of data takes longer time, so it's not a good idea. So these are the things, so these are the limitations. There are three different limitations we have seen. So we cannot increase or decrease the length of the array. So if you want to add something at a specified position, then you need to shift other element to make room. And if you want to remove an element at specified positions, you have to shift to the left side again. So these are the three different limitations, and that's why array is not proper. Array is not appropriate for you know for several problems. So we'll talk about that. We'll try to find out how to improve that one. Java list interface, we understand what is interface, and list is an interface. Java library has a list interface, and it provides several methods, and these method basically, using that list interface you can create some array, or you can create some, some other list type information. So we have discussed in the first week that under the list, we can have linked list, we can have an array. So you can create some array, or you can create some, linked list on the list interface. So method these are the methods that we can find from list interface. So what are the methods? So return a reference to an element at specified locations. That means you can find the index to an element of a specified location, find a specified target value, add an element at the end of the list, insert an element anywhere in the list, remove an element, replace an element in the list with another, return the size of the list, sequentially access all the list elements. So these are the method that you can use these operations under, under a list interface object. So if you create any class and that implement this list interface, then you probably have these kind of methods. These are the methods that are coming from a list interface, and you can override this method. You can, since interface doesn't have implementation, so you have to implement these sort of things. If you just implement, and if you just, implement list interface. So what we have seen over here, these are the some, some example from the previous slide. How do they look like? Say for examples, this is one method, get method. That get method return the data in the element at position index. So we are passing some index using the get method, and it returns the data of the given index. Set method basically taking index and taking some, data. So we are inserting some data at specified index. So this is the set method. Size method return the current size of the list. Add method, and we are giving some data. So and these data will be added at the end of the list. So index of, so we are giving some data over here, so it returns what is the index of that data in the list. remove method Remove method, we are giving some index over here, it will remove the data at the given index. So these are the some method which are declared in the list interface. So if you create a class and you implement list interface, probably you have this method, and then you can implement this method to for your purpose. So this is the list interface hierarchy. So you have list interface, and under this list interface you have another class called abstract list, and under this abstract list you have several classes: array list, vector, abstract sequential list, and after under the vector you have stack, and under the abstract sequential list you have linked list. So in this course we'll talk about the array list today, and we'll learn about the stack, and we'll learn about the linked list. So that means we are learning almost all three, we are learning all three classes. Those are very important. So these are the things. So today we'll start with the array list. So Arraylist is a class. We have seen this. Arraylist is a class under list interface. So Arraylist object is an improvement over an array object in that it supports all the operations just listed. So Arraylist array object that we have seen, array has some limitations. So Arraylist probably have some improved solutions, so it can eliminate some limitations that we have seen in the array. So we'll see what are the solutions they can provide. So Arraylist under list interface, so it supports all operations just listed. So it supports all these operations, all these methods in the Arraylist, because this Arraylist under list interface. Since Arraylist under list interface, so it can support all the method that we have seen over there. So array list objects are used most often when programmer wants to able grow a list by adding new element to the end, but still this capability to access the element in arbitrary order. So we know that we can access any element in an array by specifying index. So so it's very simple that you give some index and you can easily access any data from that array. But the problem is that in array that you cannot grow your array. That means you cannot increase your array length, you cannot decrease your array length. But in using array list object, that you can do that. You can increase your array length automatically, and at the same time you can access arbitrary value by using by giving some index. So this is the good thing that Arraylist have some capability of that. So how to declare an array list? Say for examples, you have list and you have a string. So that means this basically saying that you are declaring a object name is your list, and this object of list interface or list class list interface, and it can keep only string information. So these basically we are creating a list that can keep only string informations. Then you have to uh, yeah, create some memory spaces for your list. So you allocate some memory space using some this array list constructor. So then this is the way how you can create a object for array list. And this is the another way, so you can follow one of them. This is one way and this is the second way. So in the second way you can create in that way. So this is my list object of new array list, and list in the that can keep only string data. So these are the two different way you can create array list. Let's see some example on the terminals. Say for example, if you go to we this how to create some array list. So we import java.util, and uh, uh, then we have a class called kw arraylist. So this is class name. So then we write e basically is some type we don't know, so it's some uh, you know uh, we didn't specify this is string or this is integers or this is float. So that means this array list can keep any kind of any type. So if you keep, you can keep string, you can keep integers, you can keep float. So you are not specifying that this array list only for string. So you can create an object of the array list, this kw array list, and you can keep any type of data. So initially we have some initial capacity of the array list. We keep 10. If you need more space, then you can add more spaces. So you have some data, you declare some members for the array list, the data that you want to keep in that array list. This is e type. Here also we are not specifying any type, so it can be any type. Then you have size, and you have some capacity, how much capacity in the array list. This is the constructor array list. So now you can go to some so you declare add method, so that you know that this k this one this kw array list basically need some method. So we are declaring some method, we are implementing some method, add method. So add method will add any element at the end of the list. Then we'll talk about the so add method if size is equal to capacity, that means in the add method it's talking about size equal to capacity. That means if you don't have any space to add any element to the list, then you need to grow your array. So how do you grow your array? So you call reallocate method. That reallocate method create a new array, which is the you know double of your current capacity, and basically it copies all the data from your old array to your new array. So this is kind of a reallocations method. So if you have new if you need spaces, if you don't have spaces in your array and you want to insert a new element, then what you are doing, you create a new array which is a double size, which has a double size of your current array's capacity, and then it copies all data from your old array to your new array. So these sort of things are basically happening in the array. If you create an object of an array list, then you don't need to implement these sort of things. This is kind of it that we are talking about this this coding because we just want you to understand everything. But if you create an object of the array list, you don't need to implement these sort of method. You can easily yeah, you can easily call this method, and you can easily access those method. Then another add method. In this add method, if you specified some index and data, that means you want to add some data at specific index. So, and the previous one was add method without giving any specified index. So it basically adding at the end of the list, and this one adding element at some specified method. Then you have a get method. Get method return some values from specified index. So every time you check whether there is an exceptions or not. So array index out of bound exception, basically telling that so we are inside the array, we are not out of bound of the index. Set method, if you want to set something, if you want to update some value at some specified method, then you can call set method. Then remove method, and some these are the remove method. If you want to remove any value from a specified index, then you can call remove method. So this is the way you can create your own array list. So that basically you know uh, this kw array list is not using array list object. But if you want to use your array list object, so you can, if you want to use built-in array list object, say for examples here in this class we uh, keep that name my array list. In the main function you can see that we create an object my list, and which is an array list, and then you can easily call add method, set method, remove method, index of method. You don't need to implement any of them that we have done in the previous these class. In order to create your own array list, you have to implement all the method. But if you don't want to create your own array list, you can easily you know uh, use array list that is built in the Java library. You just create an object, and using that object you can use add method, set method, whatever. You don't need to implement those sort of things. So just remember how to create an array list, then you can use all those methods that we have seen in the slides. So so this is the thing that we create a my list over here, new array list. Then you can easily add call add method to add some informations to the array list. So here you can see that you have a my list, something like that. Then if you want to add something, say doc at index 2, so that basically insert a doc at this position. This is index 2 0 1 2, so it's basically insert dock and shifting the other two to the right side. So after insertion dopey, so if you want to insert dopey, so you didn't give any index, that basically dopey will be inserted, dopey will be inserted at the end of the array. And if you want to remove one, that means you want to remove awful. So if you want to index one, so after removing value at index 1, we have now updated array list. So you can see that the updated array list doesn't have awful string. So this is the way, this is the thing concept of array list. Now we have seen that that whenever we create an array list, we can specify string, that these lists always keep string value. So sometimes we we can leave it blank. So that means uh, you know uh, we can we if we don't specify string or any type over there, then it can be a non-generic. So what is generic? So generic collection allow you to define collection that contains refer to the object of a specific type. So if you specify any type over as we specified over here, string, so that basically making it generic collections. So collection is a set, you can say it's a list. So we are creating a list or we are creating a collection that is generic, and that basically keeps string type only. So if you specified some type information over here, that collection will be generic. And if you want to make so here also is specified string, because we can keep only string, and this kind of collection is called generic. And what is non-generic? If you don't want to specify anything over here, then it can be non-generic. Let's see some generic and non-generic examples. Say for examples, this is a generic class. You have a list or collections that is string. Now if you remove this one and if you remove this one, then it become non-generic. And in that case, you can keep string, you can keep integer, you can keep float. So if you specified something, if you specified in any type over here such a string, then it become generic. So this is the concept of generic and non-generic concept. So in this slides, what we have seen, that we have seen we have some limitation of arrays. So that's why we can create some array list. So we can create our own array list by declaring and defining different methods, and we can use built-in array list. We don't need to, in that case, we don't need to implement anything. We just call them and use them. They use their functions, methods. And we have seen that in these slides, that what is generic and non-generic collection, or what is generic and non-generic list. Thank you. Let's go to the next slide.